All right, so now we're down to the reflections. So what do we do with those? Well, again, we have our parent function, log base b of x, and we can put, the negative sign out in front, or we can put it with our x. If we put it out in front, what does that do? Well, that's going to change my output of the y. It's going to change it from either a positive to a negative or a negative to a positive. And so that means we're going to reflect across that x-axis. And so if we start up here and we put a negative in it, that's going to bring it down here. Or if we start here and we make it a negative, it's going to reflect it back up here. So again, it's just reflecting across this x-axis. Well, this one, guess what? When you have a 0 there, it doesn't have any reflection. So that point stays the same. So that's going to be a key item. Now, what happens to your uh, asymptote? Well, it doesn't change. It's going to stay the same. And your range is still going to go from negative to positive infinity. And so your domain is still going to go from 0 to positive infinity. And so only thing changes basically is your y values. Okay. Now, if we have a negative in here, that means if we had a positive x, it's going to become a negative x. And if we had a negative x, it's going to become a positive x. So what we're doing is we're reflecting over that y-axis. Now, does anything change here? Yeah, something does change here. What's going to change is if we initially are over here, our asymptote still at x equals 0, but our domain now becomes from negative infinity up to 0. Now, if this is our original and we flipped it over and came on this side, then it goes from 0 to positive infinity. So it all depends on where you're starting with your value as far as left or right. But what's going to happen is our domain's going to go down and it's going to go that direction now. Our range still is from positive to negative infinity, and it's going to be x equals 0 is our vertical asymptote. So what are we going to do? Well, we're going to draw a graph. And so here it says just state domain, range, and asymptote, and it doesn't say sketch your parent graph. But what is our parent graph? Well, our parent graph is log. Now, if we put that in, that's log base 10 of x. Okay. So what is our two critical points? 1, 0, and 10, 1. And so those are start points. Okay. Now, does it matter which way we do first or which way we do second? Not really. Let's do inside here first, though, okay? So we're going to change and get to the opposite of x. So that's going to give us a negative 1, 0. That's going to give us a negative 10, 1. So that's going to give us the opposite of x. Then what we're going to do? Well, now we're going to take the opposite of y. So now we're going to take the opposite of y. So that's going to give us a negative 1, 0, and a negative 10, negative 1. Okay. And so these then are going to be our points that we plot. Okay. So let's go ahead. And so we're going to be in the negative. So, and then we have 1, 2, 3, 1, 2, 3. So a negative 1, 0. That's going to be right there. Okay. And negative 10, negative 1. So that's going to be about there. So this looks to be depending on how you look at it, an increasing or a decreasing function. It's increasing if we go from left to right. It's decreasing if we go from right to left. So what happens is that's going to be where we have it. Now, our x-axis or our asymptote is going to be here, okay? Because all we've done is we've reflected it first across this axis, and then we reflected it this way, okay? And so x equals 0 is our asymptote. Our domain now is from, well, it's going all the way out this way, from negative infinity up to 0, and our range is going from negative infinity to positive infinity, okay? So that's how I do it. Again, suggest using the points like this. Start with the original, then start doing your transformations along the way. All right, now, cool thing we can do, we can use our graphing calculator to approximate the solution of a logarithmic equation. So what we're going to do is we have to enter our first part of the equation in y1, the second part of the equation in y2, and then we graph it and make sure we have our window set to see the intersection, because the intersection is going to be what helps us. And then we're going to use our second calc, choose the intersect, which is number 5, and then find the value of the x for that intersection. So what we have is solve this equation graphically. All right. So what we're going to do, well, we're going to say this is y1, this is y2, and then we're going to plot it. So let's go to our calculator. So we said that y1 was going to be 5 log of x plus 2. Okay. And then we said y2 was going to be 4 minus the log of x. Okay. That's all it has to have. Now we graph it. Well, guess what? Everything's on the window. I just had just the normal standard minus 20 to 20 and 5, and we have our intersection right there. So now let's try to get to it. Well, we're going to do second trace. We want the intersection, which we said was 5. And our first curve is blue. Our second curve is red. And it's thinking, maybe. Okay. And we'll guess that area. And it says 3.0486. It said to 3 decimal places, so 3.049. So x equal is approximately, I should say, 3.049. And so that's how we would solve that, just going to that intersection point, and that would solve this system, or this equation here. Okay. All right, so this one says, what is the vertical asymptote of this equation? Well, now this one is a key thing. This is ln. Well, how does that work compared to the normal? Well, what is ln? Well, that's log base e. Okay, and so what we would have is log base e of x minus 1, and we still have our 3 plus there. And we know that we have log base b of whatever. We just set this greater than 0. So x is greater than 1. And so our asymptote is x equals 1. Okay. And so, if we had to be greater than that, that's going to be our asymptote. Okay. And so it doesn't matter if we have log base b or if we have ln, because we know we can take ln, convert it to log base e, and we get our function. Now this is going to be a key, because sometimes we're going to be plotting these, and it might, look like that, and they say use the natural log or use the common log. And so you have to know natural log versus common log on how you do it. Common log would be log base 10, and natural log is log base e. So it kind of depends on what they ask you to look for. All right. So one last problem here. And so this one, they give us basically a function drawn out. And what we have to do is we have to find the equation. And this time, like I said, sometimes they'll ask for natural, sometimes common logs. They want the natural log here. Okay. Well, what can we do with this graph? Well, first off, is there an asymptote? Well, it looks like that might be our asymptote. And so we'll say x equals a negative 3 is going to be our asymptote. Okay. What else can we do? Well, we can find some points, can't we? Well, let's see here. Where is the nice point crossing? Well, that looks pretty nice. That looks like a negative 2, negative 1. And we kind of come up and come up and come up. Well, this one might be perfect. It might be a 4, 3, or it might be just under. Kind of hard to tell. Let's say it's that. And then if we need to, we can always round at the end to get kind of a nice, pretty numbers, okay? So let's start with this. Now, what can we do with our equation? Well, we know it's natural log, so we know it's going to be something like y is equal to. Now, if we put in all of pieces, we're going to have maybe some kind of variable here. We'll have some here. We'll have some here. So let's write all those in and see before we do it. We'll call this a because we don't know what our stretch or compression factor is. Then we know it's ln. And now we know our asymptote here. So that's going to be, we moved it left. So that's going to be x plus 3. And then we know we can add or subtract. And so let's say we're going to add k. Okay. So we have an a and a k that we need to figure out because we know that this part's done. It's just that part and that part we don't know what are. So what do we do? Well, let's plug in one of our points that we found. This one I'm more comfortable and confident with because that really looks like it's going through there. This one looks like it might be just slightly under, so I don't know. Let's see what we get. So if we plug in this, we have a -1 equals, now we don't know a still, and then we have ln, and x is -2 plus 3 plus k. All right, well, this gives me -1 equals a ln of 1 plus k. Well, what's ln of 1? Well, the ln of 1 is 0. And again, if you ever have issues on what things are, you can always come over here and say, well, what is the ln of 1? And it gives us 0, okay? So what do we have now? Okay, well, now we have -1 is equal to k, and so we have our k value, okay? And so this gives us now the new function. Well, let's just plug in this point and do it all at one time. So 3 equals a ln x is 4 plus 3, and then -1 because k is going here. So we're just going to plug that in directly. And now we can solve for a. Well, let's do that. +1 plus 1. 4 equals a ln of 7. Divide by ln of 7. And so a is equal to 4 over ln of 7. Now, we could leave it like that and just plug in our values and say, okay, well, now we have um, going with our function up here, maybe we should call it f of x equals 4 over ln of 7, and then times ln of x plus 3 minus 1, and we could leave it at that. Now, if we needed to figure out an actual value, we could take and find that too. We could take our 4 divided by ln of 7, and we get 2.0556. How about that? And so 4 over ln of 7 is approximately 2.0, 2.05. What was it again? 0.2, 2.056. Give me a pen. Okay, so that's approximately equal to that. So do we want to call it f of x is approximately 2 ln x plus 3 minus 1? Or do we want to have it 4 over ln of 7? That. Okay, well, am I 100% confident that that's a 4, 3? Not exactly. I'm not even confident that that's a -2, -1. So do we want to make it so precise to be that? Or do we run around this to approximately 2, and then we can have this function? I would say this one might be a good way to do it. You know, if they want you to have exact values, it doesn't say on this one which way to do it. We could put in the 4 over ln of 7 and have this. Or if we want approximate values, then we could say, okay, well, that's 2 ln of x plus 3 minus 1. So kind of depends on the homework. They might ask you one way or the other, and so we kind of have to figure out what that is. But in this case, I'm going to say it's going to be approximate because I'm not too sure about that actually being right on that 4, 3. All right. So that's all I have for this section. Hopefully that will help.